Hey guys, I was going to just do a little short subject today about pneumatics. I know some of you guys are working on some power drawbars, and what Ray Kniglia started. He started by building the control, and he's essentially built a 3-port non-exhausting valve, 3-position. So it's got 2 operating positions and 1 idle position. And I was going to kind of explain to you the different types of valves and then go over your specific application and show you how to make it work. And Ray, I see it. You're going to try to use 2 air cylinders, and I think I know why. You're trying to do 2 different things. You're trying to run a butterfly or a handheld impact in opposite directions, but you still want the air cylinder to do the same thing every time. And you can do it with 1 air cylinder, and I'm going to show you how. And I think a single air cylinder is going to kill 2 birds with 1 stone. You could center mount that air cylinder. Here, I got a couple air cylinders here. If you've got these guys here, and this one works on the up, and this one works on the down, and your top plate, it wants to move up and down, but also it wants to pull down this way, and then down the next cycle it wants to come down this way. So it's doing this, and eventually you're going to wear out that top plate, and it's going to get jammed up and locked. And instead of running 2 side by side the way you are and teeter-totter in the top plate, like I'm saying, let's get you 1 cylinder dead center up in the middle. Push straight down, straight up, dead center over that butterfly, and pushing down on the drawbar. And I'm going to show you how to plumb that and get the logic into it pneumatically. And the valve you have is going to work that you've already made. That's just a 3-port valve. It doesn't need to exhaust. Cylinders require an exhaust, but butterflies do not. And you're sharing the circuit, so the butterfly is going to act as an exhaust for the cylinder. I'm going to show you, here I wrote some down to kind of help you. There's 3 types of air cylinders. There's a mechanical over air, air over air, and electric over air. Mechanical over air is what Ray has built. That just takes mechanical motion directly on the air valve to operate it. Air over air is where you take a pilot device, a remotely mounted pilot device, and run small air hoses from the pilot to the main spool or the main valve, and let that pilot operate the main valve. And so you take small hoses back and forth from the pilot, and then the big slave valve is what does your air switching. And that would be the complex valve, the spool, and that could be up, it could be up a 4, 5, 8, 10, 12-port valve that does many things from many different remote locations. The other way is electric over air. And I've got some solenoids I was going to show you. That's just, these are very compact, nice little solenoids. Take a 1/4 inch, we got 1/8 inch pipe, but they take a 1/4 inch line with the Presto Lock fittings. And this is a 2-position. That's another thing we got to talk about, the 2-position and 3-position type valves. This one, when power is applied, it puts air in this way. When power is removed, puts air this way. Pretty simple. But there's no center position. There is no off. What Ray has made is a 3-position. And that's called a closed center. See, in a 3-position, you can have an open center or a closed center. In a 2-position, there is no center, so we don't refer to those as open or closed. And that's the same for all 3 types of valves. So in these 3 types, you've got 3, 4, and 5-port in all 3 types. In all 3 of these types of valves, you've got 2-position and 3-position. 3-position valves are the only ones that are going to have an open center or a closed center. And I'm going to walk you over to the mill and show you a 3-position mechanical with a closed center and show you how it operates. That is operating an air motor, so that one requires an exhaust. And it has that is a 5-port valve because you use the 2 extra ports to exhaust. Now an impact or a butterfly is self-exhausting. It's bleeding its own air off out of the butterfly, so you don't need to run an exhaust. And let me walk you over to the mill and I'm going to show you that. Okay, here's an example of a mechanical over air 5-port valve. Your incoming air is the black. This is line pressure. This goes off to my load, which is up, down, in, out, whatever you want to call it, up and down. And then the other two, these little sintered bronze elements, those are just an exhaust. And so this is a closed center 3-position 5-port valve. You have to know all the parts of a valve. And reading those little charts on here isn't as hard as it looks. If it's a 3-position valve, each one of those boxes represents a position. I'm trying to focus on that and it's not focusing. Let me get my finger out of the way. The box on the left indicates the up position. The box in the middle indicates the center position. And the box on the bottom represents the down position. So here's down. Hang on to your ears. That's my power access feed. But anyways, in the neutral position, you can see all the valves are blocked. So this is a closed center valve. And on this side, that's when I just pulled the lever down. That's this box. And if I was to push the lever up, that would be this box. So that's how you read those diagrams that you see on the side. And each one of those, there's a number on the port, and it shows an arrow either connecting the ports, or it shows a little line going across showing the port is blocked. And there'll be either a number or a letter, and there's a number or a letter right next to each port. So that's going to kind of help you out with your valving. All right. This one is running an air motor. I've got that white line coming around to a little gassed air reduction motor here, and that runs my my Z-axis feed because I get tired of cranking a handle. Essentially, I'm a lazy guy, so that's what that's running. But anyways, that's a good example of a mechanical over air valve. Okay, and we're back, and now we're going to talk about air cylinders and air cylinder speeds. This is just your garden variety air cylinder. These are just open fittings. There's nothing special about these fittings. They're just little swivel push to connects. But that air cylinder there's a rocket. Put air to it, boom. Take air the other way, boom. It's just full speed ahead. And this thing will hammer the shit out of it. This thing will hammer the hell out of itself in no time. What you do to prevent that, these are needle valves that are actually built into a very nice little swivel. And the metering valves right here. And what that does is that dampens the operation. I'm pulling on that as hard as I can and pushing on that as hard as I can. And you adjust the needle valve to control your speed. That does not change the operating force of the cylinder. All it does is change the operating speed. So based on your pi calculation for the diameter of the cylinder and your line pressure coming in, the speed is going to be very slow. But after it applies the pressure and the pressure builds in the line going to the cylinder, you're still going to get the same amount of force, whether you use 40 psi, 80 psi, 120 psi, whatever. Operating force and cylinder speed have nothing to do with each other. All right, let's draw your circuit that you want to use for your power drawbar. And what we're gonna try to do is use your 3-position closed center valve that you're already making to run the butterfly. We already know it's going to run the butterfly fine, but we want to run a single cylinder in the same direction no matter whether you're going forward or reverse. So we want to reverse the butterfly, but we obviously want the air cylinder to work the same in both up or down, or in or out, whatever you want to call those buttons. You find a couple colors here. Oh, I need a little more room to write. Let me erase some more stuff. So much for the shop needs. I guess I don't need anything anymore. Okay, so we're going to have an air cylinder here. We're going to have a port here, and a port here, and a rod. And then we're going to call this your butterfly. And we're going to have two ports there. And that's that represents your socket right there. How's that? And now we've got a 3-port valve here. And here we'll just do the 3 ports here. All right, you got that? Are you getting all this? Oh yeah, good. All right, red is going to indicate line pressure. Blue is going to be deflated. So first we're going to draw air to there, and then we want to pressurize here. And I'm actually going to draw the T. There's going to be a T there. And these are going to remain a constant. I'm running out of room again. And blue is depressurized. And red is pressurized. Now, what those 2 arrows represent is a check valve. That is a one-way valve, and you can get very miniature ones. They're going to screw directly on the cylinder. And this valve will allow air to flow this way. So air is going to come in here and charge the back of the cylinder. So the cylinder is charged here in the back. So line pressure in, switch activated in the up or down or in or out, whatever. This line is charged. Your impact is running. It's flowing through that check valve and filling the cylinder, creating a downforce on the cylinder. Okay, let's erase that and switch the circuit the opposite way. Remember, we've got a check valve here, so you're blocking right here. All right, so let's draw this the other way. Oh, aren't whiteboards fun? Okay, now we're going to press this 3-way valve. We've still got line pressure here. That's just your incoming air. Now we're going to press this switch in the opposite direction. Now we're going to put air on this side, apply it here. We're going to fill up this T with air. We're going to pressurize the cylinder again. But remember, now we're blocking right here with that check valve. So now you're blocking here, so this remains unpressurized to there. Okay, so your air cylinder is acting the same way and doing the same thing no matter if you switch your impact forward or reverse. It does not matter. That air cylinder is going to act the same way. And so I think the cylinders you guys are using are going to work, but you only need one. You don't need to do 2 of them. And that gets rid of the rocking problem for the top. And as far as your cylinder speed, don't worry about that. I got a bunch of these things. I'm going to take these needle valves off. These are 1/8 inch NPT, and they take a 1/4 inch poly line. I'm going to send Herb, Blair, Ray Caniglia, and Colin. I think you guys are the only ones that are building your drawbars. I'm going to send you guys some of these needle valves that you can put on your air cylinders to control your speed. What you do need to buy, you're making your own 3-way valve. I know you guys got air cylinders already. I'm pretty sure you got butterflies. I don't have any anyways. What you do need to get are 2 small 1-way check valves and use those as blocking valves to make that single air cylinder perform in both directions of the impact. All right. This was just a short slam together video to get you guys on the right track and set up the pneumatic logic on your power draw bar. All right, guys, enjoy. See ya. Bye.